Good evening, students. How are you all? Hello, Shillong Center. So, Sonu, only you are present there today? Okay, so today we have to start the chapter real number. That is the first chapter according to our syllabus, the real number. So before starting this chapter, in the 9th class, you all have studied the chapter number system, in which you have studied about the different types of numbers like natural number, whole number, integer, rational number, and irrational number, and how to differentiate between rational and irrational, and how to convert the decimal expansion of non-terminating or non-repeating decimal expansion into P by Q form, and these types of questions you have done in the 9th class. So in this 10th class, in this real number, what we will do, we will discuss some of the topics like Euclid division lemma, and how we can, what is this Euclid division lemma we will study, and in this one we will learn how to find the HCF, how to find the LCM of the numbers, and second thing we will mostly study about the factors, which is known as fundamental principle of counting, and then we will learn, in the 9th class you have studied about the what are rational number and irrational number. So in this one we will proving irrational number, like we will prove that the given number is irrational. Like in the 9th class you have studied that you know that root 2 is irrational, but how can you say root 2 is irrational? How will you prove this one? So we will learn this thing. So these are the major topics in this chapter which we are going to study. Oh, because of the heavy rains. Okay, that's not an issue, so we will continue. Then rest can watch the video later on. Okay. So, starting with first part, which is known as divisibility. So divisibility means, like, suppose if you have two numbers, let's say 4 and 2. So you can say that 2 divides 4, and if you have 10 and 5, so you will say 5 divides 10. So if one of the number is exactly divisible by other number, we will say that first number is a multiple of second number. Here 4 is exactly divisible by 2, so we can say 4 is divisible by 2, or you can say 4 is a multiple of 2, or we can say 2 divides 4. So if we have two numbers A and B, so the notation to write these number is that if I am writing like A, then this vertical line, and B. So what is the meaning of this representation? It means A divides B. Either we can say A divides B, or you can also say B is divisible by A, or you can say B is a multiple of A. So there are many ways in which you can say. So if I am writing 7, this vertical line 21, so it means the meaning of this thing is that 7 divides 21, or you can say 21 is a multiple of 7, or you can also say 21 is divisible by 7. So this is the notation. If I am writing two numbers like this, it means A divides B, or B is divisible by A. So if I give you like this, suppose some of the questions based on this one, and you have to tell me whether these are true or false. And dividing means, like whenever you are dividing something, there should be some integer. Like when we are dividing 21 by 7, it goes 3 times. So 3 is a integer. Similarly, if I am dividing 4 by 2, if I am writing 2 by 4, so it means 4 is divisible by 2 for some integer, and that integer is 2 because 2 times 2 is 4. Similarly, if I am writing 6 oblique 18, so it means 6 divides 18 3 times. So if you are writing A divides B, so that should be equal to B is equal to AC. Here C has to be some integer. For some integer C, A will divide B. So if I ask you like this, whether this statement is true or false, so you have to check. The meaning is that 3 divides 93. If the answer is coming out to be an integer, like 3 times some integer is 93, then you will say it is true. Otherwise, it is false. So like check for this one, like whether they are true or false. 3 divides 93, then 6 divide 28. Check for these 4. How second is true, Shillong? Sonu, how second is true? And how third is true? Third means I have written 0 divides 4. How can you say that 0 divides 4? 0 divides 4 means we are writing like this 4 upon 0, and you all know that whenever the denominator is 0, that is not defined in mathematics. So this is mathematically wrong, this statement. So this is definitely false. The meaning of this thing is that 3 divides 93. So when I am dividing 93 by 3, the answer is coming out to be 31. 31 is an integer. So this is true. And 6 divides 28. Now 28 divided by 6, it will be 14 by 3. And 14 by 3, we will not get any integer over here. So it means this one is false. And 13 divides 25. No multiple of 13 is equal to 25. So this one is also false. So only first one is true. Itanagar, I am saying that the notation to write the number like this, if we are writing like A, if you are writing in this notation A, then vertical line and then B, the meaning of this notation is that you have to read this one as A divides B, or B is divisible by A for any integer C. So like if I am writing 7 and line 21, so it means 7 divides 21 for some integer 3. Similarly, if we are using this, it means 2 divides 4 for some integer 2. 6 divides 18 for some integer 3. So we have to check on dividing the second number by the first number, the answer comes out to be an integer. Then only this statement will be true, otherwise not. So these are 4 true and false. So it means 3 divides 93. So 93 divided by 3, the answer is coming out to be 31. So 31 is an integer. So this one is true. Second one is 6 divides 28. If you divide 28 by 6, you will not get any integer as your answer. That's why this is false. Third one says 0 divides 4. Now mathematically, denominator 0 is not defined in mathematics. So 0 divided by 4, 0 divides 4 is mathematically wrong. So this one is definitely false. And 13 divides minus 25. Again, 13 does not divide 25 for some any integer, so this one is also false. So this is the meaning of A, that symbol, and B. Now after this, Euclid division lemma. Note down this statement. Euclid division lemma, that is the first subtopic which we have to study in this one. Good evening, Presidency College. Okay. So Euclid was the name of the mathematician. Division, you know, the process of dividing. And lemma. What do you mean by lemma? Lemma is a proven statement. Proven statement means the statement which is already proved. We don't have any proof to prove this statement. It is universally accepted. That is called a lemma. Already proven statement, that is called a lemma in mathematics. So Euclid division lemma talks about the principle of dividing. So it says, let A and B be any two positive integers. It tells us about the positive integer. If A and B are two positive integer, then there exist unique integers Q and R such that A is equal to BQ plus R. What do we mean by this thing? When we yes, Itanagar, 6 oblique minus 12, that will be true because 6 divides minus 12 for minus 2 times. So that for what number it is dividing, that should be integer. So 6 divide minus 12, that is true. And algorithm we will study. Algorithm is basically to find the HCF, that is called the algorithm. We will study. So Euclid division lemma says, if A and B be any two positive integers, these are the two positive integers. There are 5 types of integer: positive, negative, 0, non-positive and non-negative. Positive integer means starting from 1, 2, 3, 4, 5. Negative integers means on the left of minus 1, minus 2, minus 3. 0 is an integer which is neutral. So if A and B be any two positive integer, then there exist unique integer Q and R. There will be two unique integer Q and R. The relationship can be written like this: A is equal to BQ plus R. So basically it means, suppose out of A and B, if A is greater than B, and if we are dividing A by B, if we divide A by B, so there must be some quotient, B times something, and then there must be some remainder which is R. So Q and R here basically represents the quotient and the remainder. So when we are writing A is equal to BQ plus R, this is here A is called dividend, B is called divisor, Q is called quotient, and R is called remainder. And this is the division algorithm which says dividend is equal to divisor into quotient plus remainder. So you can say dividend is equal to divisor into quotient plus remainder. So Euclid, the difference between the lemma and the algorithm, only difference is that lemma is the statement which relates the dividend, divisor, quotient and remainder, and Euclid division algorithm. Yes, this Euclid lemma is only valid for the A and B has to be positive. It is not valid for the negative. This statement only talks about the positive integers, A and B. They have to be positive. Is it clear? So A and B has to be positive, they will not be negative. So this is called the Euclid division lemma. Now there must be some conditions on the remainder also. When we are dividing something, let's say if you are dividing 7 by 3, so you will get 3 times 2 which is 6, so remainder is 1. If you are dividing 7 by 7, then 7 times 1 which is 7, remainder is 0. So is it possible that you may get remainder as negative? Division you already know. Is it possible that you are getting a negative remainder? Yes. So negative remainder is not possible. It means the minimum value of the remainder is going to be 0. And we also know that the remainder is always less than the divisor. Like if I do this calculation, tell me whether I have done it right or wrong. If I divide, let's say 16 by 4, so 3 4s are 12 and this is 4. Have I done this division right or wrong? And if it is wrong, what is the mistake in this one? Shillong, how it is right? This is wrong. When you are dividing 16 by 3, so we have to look for that multiple of 3 which is just less than 16, and multiple of 3 which is just less than 16 is 15. 3 times 5. So we have to do it like this. 16 divided by 3. So this statement is wrong. When we are dividing 16 by 3, we will do 3 times 5 which is 15 and remainder is 1. So here, since this statement is wrong, and here you can see the remainder which we were getting was greater than the divisor. So eventually that is wrong. So in the end, this is the correct one. So remainder, quotient is 5. Remainder is always, remainder is not greater than the divisor. Remainder is should be less than the divisor. So the condition on the remainder, what can you say? It can be 0, it can be greater than 0, but it is always has to be less than the divisor. So you can add one more point over here. There, if A is equal to B cube plus R, the condition on the R is that R has to be greater than or equal to 0, but it is always less than the divisor. This is the condition on the remainder. So if let's say, if a very basic question, if divisor is 3, so how many different values of remainder are possible? If divisor is 3, then how many different values of remainder are possible? Very good. So remainder can be either 0, it can be 1, it can be 2, but it will never be equal to 3. So 3 different values of remainder are possible. Yeah, that is correct. So if my divisor is 5, so 5 different values of remainder are possible, starting from 0, 1, 2, 3, 4. Okay. So now, So this was the Euclid division lemma. It talks about the relationship between the quotient, remainder, divisor and dividend. Now, what do you mean by Euclid division algorithm? So algorithm is nothing but a collection of steps which we perform to get some desired result. So the series of steps which we are performing in any question to get the desired result, that collection of all those steps is known as algorithm. So how we can apply this Euclid division algorithm to get different desired results? So this Euclid division algorithm is basically helpful in finding the HCF. It is helpful in finding the HCF of the numbers. So how we can use the Euclid division algorithm to find the HCF? So first one is in finding HCF, how we can use this Euclid division algorithm. So in this Euclid division algorithm, what we will do, we will take the help of Euclid division lemma. So it says for any two numbers, positive numbers or positive integer, I must say, A and B, where A is greater than B. So A is equal to BQ plus R. That is the Euclid division lemma. Now how we will use this Euclid division lemma in finding the HCF of the numbers? So first of all, before using this one, I would like to know what do you all of you mean by HCF? What is the full form of HCF? Yes, highest common factor. So the other name for HCF, first name is highest common factor. This is also known as GCD. Sometimes the HCF is also known as GCD, that is known as greatest common divisor. So either you can say HCF or you can say GCD. So we will learn using that Euclid division lemma, how Euclid division algorithm, how we can figure out the HCF of 2 or 3 numbers. So first of all, if it is like 12, 18 and 24, tell me the HCF of these 3 numbers by any method which you know. Right? So 6 is the HCF, 6 is the largest number which is common to all of them and divides all of them. Right? But how we can use this Euclid division algorithm to find the HCF? So there are certain steps. So let us start with one example. So suppose the question says find HCF of 210 and 55 using Euclid division algorithm. This is the question, like find HCF of 210 and 55 using Euclid division algorithm. So in this one, first of all, we have to figure out of these two numbers which one is greater. So as clearly we can see that 210 is greater than 55. So what we will do, the steps are like this. Using the long division method we will perform. First, this 210 will become the dividend and 55 will become the divisor. So right now we know that 210 is not a multiple of 55. So we will do just the normal division. So it will go 55, if we do 55 4 times, that will be 220. So we will go for 55 3 times. If you go for 55 3 times, we will get 165, and on subtracting we will get 45. Now you know that the remainder is not equal to 0. If the remainder is not 0, then in the next step what we will do, that 55 which was divisor in the previous step, this time it will become dividend. So this same 55 will become dividend over here, and then we will divide again by 45. So now we can see it will go 45 one times, then the remainder is 10. Again we can see that the remainder is not coming out to be 0. So the divisor in this step will become the dividend in the next step. So in this step of division, divisor was 45. So that 45 will become dividend for the next step. So here it will be 45. Again it will go. So 10 4 times 40. We are getting remainder as 5. Still it is not 0. So again the divisor in this step, which is 10, will become dividend in the next step. So 5 2 times 10. Now in this step we are getting the remainder as 0. So the division step in which we are getting remainder as 0, that divisor, the divisor over here is 5. That divisor is known as the HCF of two numbers. So we have to do this division process completely, and the step in which we are getting remainder as 0, the divisor in that step will be the HCF of two numbers. So here 5 is the HCF of given two numbers. Yes, Tamenglong, you have given the right answer. Now, Shillong, I think you should focus on studies, right? Sonu. Okay. Now we can also write this complete division process in the form of algorithm. So we have to write this complete in the form of algorithm. So how we can write it like this? If we start with the first one, so dividend, which is 210, is equal to divisor into quotient plus remainder. Now for the next step, this divisor becomes the dividend. So 55 will come over here, and that remainder becomes the divisor. So it will be 45 times 1 plus 10. Then for the next step, this 45 will become the dividend, and this 10 will become the divisor. So it will be 10 into 4 plus 5. Then 10 will become the dividend, and 5 will be the divisor. 5 into 2 plus 0. So here 0 we are getting over here. So in this step, whatever is the dividend, which is 5, this is known as the HCF of the two numbers. All of you are getting it? This method of finding HCF using Euclid division algorithm, the continuous division process we have to perform until we get a 0. And if we get the 0, and in that step, whatever is the divisor, that is the HCF of the number. All of you are getting it? Itanagar, Presidency College, is that clear? Tamenglong? Okay, so using the same step, solve this question. Find HCF of 4052 and 12576. And this method is very helpful in finding HCF of large numbers. Like you can see, it is a 4-digit and 5-digit number. So using this Euclid division, it is very helpful. Yes, Sisipur, that is right. Yes, Presidency College, that is correct. Very good. Shillong, Tamenglong, Itanagar, what's your answer? Divide 12576 by 4052 in the starting, like this. And directly you can see this is 12,000 and this is 4,000. Approximately you can see you cannot go 4 times. You can do it only 3 times. So 4052 into 3, 12156. Then on subtracting you will get 420. Now again this 420 will become the divisor and 4052 will become the dividend. So now dividing it by 4052 by 420, and you can see that 420 into 10, that is 4200, and it is less than 4200, a little bit is less than 4200, so it will go 420 into 9 times. So when we will do 9 times, it will go 3780. On subtracting you will get 272. Now this 272 will become your divisor and dividend will be 420. Now you cannot go twice, it will be only once. 272 into 1 is 272. On subtracting we will get 148 we will get. Now 148 will be the divisor and this 272 will become the dividend. So now we will go 148 into 2 we cannot do, it will go 148 into 1s, and 148 into 1, that will be 148, and the remainder it will be 124, and now 124 will be the divisor and 148 will be the dividend. 124 1 times, which is 124, so 24 will be the remainder, and then it will be 124 times, 24 5 times 124, and then it will be 24, and finally we will get 24 into 4 into 24, which is 6 times. So 4 6 are 24, remainder is 0. So in this step we are getting remainder 0, in which the divisor is 4. So this is the HCF. HCF is 4, Shillong 4. See, last में जाके यहाँ पे 4 आ रहा है. The step you can see complete steps. It should be 4. Itanagar, is this clear? Are you getting it where you were doing wrong? 4 should be the HCF. Shillong, clear hai? So take care of the calculation. There might be some long calculation in this one in finding the HCF. Now, the next thing which we have to learn, the next type of question based on the HCF will be like this. Find HCF of 81 and 237 and express it as a linear combination of 81 and 237. So this is the question in which the first part says find the HCF of these two numbers using Euclid division algorithm. Second part says whatever HCF you are getting, you have to represent that HCF as a linear combination of 81 and 237. Now what do you mean by linear combination of 81 and 237? Let's say, suppose the HCF you are getting as K, the HCF of 81 and 237, let's say you are getting K. Now K should be represented as a linear combination of 81 and 237. It means K should be equal to 81 times A plus 237 times B. So basically you have to figure out the values of A and B. What values of A and B should we use? It can be positive, it can be 0, it can be negative. A and B are integer basically. So what integer values of A and B we should use, so that on multiplying with 81 and 237 and on adding, we should get K as our answer. So you have to write K like in this form. This is called representing K as a linear combination of 81 and 237. I am saying the question, Itanagar, the question says find the HCF of 81 and 237. So that is the thing you already know how you can find the HCF. Second part says represent that HCF, whatever answer you are getting, you have to represent that as a linear combination of 81 and 237. What do we mean by linear combination? Linear combination means it should be a linear equation in two variable x and y. So suppose the HCF you are getting as K. So 81 and 237, the HCF of 81 and 237 is K, which we got. After this, what we will do, you have to write K is equal to 81 times some integer plus 237 times some integer. So basically here you have to find the values of A and B. What values of A and B will satisfy this relationship? Writing K in this form is known as linear combination of 237 and 81. So basically our aim is to write K in this form. So first we will find K. So again 81 and 237. So starting with this 237 and 81 over here. So it will go 81 two times. 162, remainder is 75. Now this 81 will be the dividend. Now this 75 will be the dividend. And now this 6 will be the dividend. So right now we have written like this. So first of all, after it is very easy to write it in the division form. So just write on the right side of this one, write all the algorithm steps. Algorithm steps will be like this. 237, that is equal to dividend into quotient plus remainder, which is 75. Now 81 is equal to divisor into quotient plus remainder. With the help of this flow chart, we can write these algorithm. And then 75 is equal to 6 into 12 plus 3. And then 6 is equal to 3 into 2 plus 0. So this is 0, so 3 is the HCF. So basically we have to write 3 as a linear combination of that 81 and 237. So we will take the help of these steps in writing that. So we have to do the starting from the last step and then we will go to the top step. So how we can write it like this? So first of all, the dividend, we have to start from the second last step. So 3 is the HCF. So you can see 3 is present over here. So from this step, how we can write 3? This 6 into 12 will go on the left hand side. So we can write 3 is equal to 75 minus 6 into 12. So what I have done, I have just taken this 6 into 12 on the left hand side. Now again in the next step we have to change. So how we can change? Just see, now before this step we have 6 over here. So we have to replace this 6 with the help of this second step. So in place of 6, we can, from the second step, 6 can be written as 81 minus 75 into 1. So in place of this 6, we will write 81 minus 75 into 1, and this multiplying by 12 as it is. So we will simplify this one first. So don't multiply both of them, just write it in the multiplication form. So we will write 81 into 12 and this will become plus 75 into 12. On opening the bracket, it will be like this. Now this is 75 into 12 and 75 into 1. So adding this one and this one, we can take 75 as common from both of them. So it will be 1 plus 12. So we can write this one as 75 into 13 minus 81 into 12. Now again, we have to go through the first step. In the first step, the remainder was 75. So we will replace this 75 in our algorithm. So 75 can be written as 237 minus 81 times 2. So we will write this 75 as 237 minus 81 times 2 into 13 as it is, minus 81 into 12. Now we will simplify this one. So how we will simplify again? Just distribute this 13 in both of them. So 237 into 13 minus 81 into 26 minus 81 into 12. Now we can see this 81 is present in both of them. So if you take 81 as common, so minus 81 is common, you will be left with 26 plus 12. So 237 into 13 minus 81, 26 plus 12 is 38. And we can write like this also, 237 into 13, taking this minus sign inside the bracket. So plus 81 times minus 38. So here we have written like this, 237 times some number plus 81 times minus 38. So finally, if we compare it with we want to write that one as 81A plus 237B. 81A plus 237B. So if we compare both of them, the value of A comes out to be, which is the coefficient of 81, which is minus 38, and the value of B, coefficient of 237, which is 13. So this 3 can be written as 237 into 13 plus 81 into minus 38. This is known as writing the HCF in terms of linear combination of 237 and 81. So again, what we have to do, so let me tell you once again, just to concentrate. First of all, note it down the complete thing. Now let me tell you once again what we have to do in this one. First of all, the basic step is find the HCF using this division method. This is also known as the long division method. After finding HCF, write the algorithm, this algorithm. Now we have to start from the second last step of the algorithm. So second last step of the algorithm is this one. So here whatever is the remainder, that is our HCF. So we will write this, start with this remainder. So we will write 3 on the left hand side and all the things on the right hand side. So 3 can be written as 75 minus 6 into 12. Now our aim should be, we have to eliminate, in every step we will take the step of the previous step and we will eliminate the remainder. So after writing 3 as this one, now we will go to the previous step. What was the remainder over here? 6. So we will replace 6 with the help of 81 minus 75 in this step. So we have written this 6 as 81 minus 75 into 1. We will simplify this one. And again on simplifying, we will take the help of step number 1, in which the remainder was 75. So we'll again replace that 75 as 237 minus 81 into 2. So we have replaced that 75 as 237 minus 81 into 2, and we will rearrange all the terms and make sure while rearranging never multiply the numbers. Multiplying the number means don't multiply that 75 into 13, otherwise you won't be able to replace it. So on rearranging, we have to take care, what thing we have to take care in mind, that we should get our answer in terms of 237 and 81. So we'll keep 237 and 81 as it is, and we will simplify all the terms, so writing the final expression in this form. Getting it, Shillong? सोनू समझ में आ रहा है? CC4, are you getting it? Presidency College, Itanagar, Tamenglong, Tetso. Yeah, now I am giving you one more example. So this time try this one. So do it like this. Solve this. Find HCF of 65 and 117 using Euclid division, and then represent it as a linear combination of this. So like if HCF is k, so you have to write k is equal to 65x plus 117y, where x and y are integers. Try this. That is correct, Itanagar. Perfect. That is right, Shillong. And what is the HCF, Shillong, you are getting? Hmm. 13 is the HCF, that is correct. CC4, CC4, your answer is not right. Okay, let me solve it. So 117 into and 65. So first we will divide 117 by 65. 65 1 times 65. 52. Then again we will take 65. 13. So we are getting remainder 0. So HCF is 13. Now the algorithm we can write 117 is equal to 65 into 1 plus 52. Then 65 is equal to 52 into 1 plus 13. Then 52 is equal to 13 into 4 plus 0. Now we will start with the second last step. So it has only 3 steps. So it is very easy one. So we'll start with this 13. So we will write 13 as 65 minus 52 into 1. Now we will replace this 52 with the help of previous step. So 52 can be written as 117 minus 65 into 1, and this minus into 1 as it is. And now we can simplify this one as 65 minus 117 and plus 65. On multiplying by 1 we will get the same thing. So 65 into 2 minus 117. So 65 into 2 plus 117 into minus 1. So we can say x is equal to 2 and y is equal to minus 1. Getting it, CC4? No, Shillong, it's not affected. Okay, so we will take a quick break over here. Then after the break, we will do some different types of question on finding the HCF. Okay, welcome back. So till now we have done how to find the HCF and how we can write that HCF as a linear combination of those two numbers. So now the one important point over here is that, like in the previous question, if we have written 3 as 65 into 2 plus 117 into minus 1. So the question is this the only way to write this form, this 3 as in this form, or there can be some other way also of writing 3? Like, is there any other set of values of x and y also for which we can write 3 as a linear combination of 65 and 117? That is the question. So the answer is there are some other ways also in which we can write 3 as a linear combination of 65 and 117. So now how we can write? So suppose the question is, let us do one question. So question is like, if D is the HCF of 56 and 72. 56 and 72 are two number, and HCF of 56 and 72 is D. So first we have to write D is equal to 56x plus 72y. Show that x and y are not unique. So show that x and y are not unique, it means there can be some other set of x and y also which satisfy this relationship. So first of all we will figure out the HCF of this one. So 72 and 56. 56 1 times 56. Then 16 3 times 48. Then 8 2 times 16. So remainder is 0, so we can say 8 is the HCF. Now we will write the algorithm. So this is the algorithm which we can write. So here starting with 8, so we will write 8 is equal to 56 minus 16 into 3, and then 16 can be written as 72 minus 56. Then into 3 as it is. So here we can write 56 times 4 plus 72 times minus 3, which we are getting. Now, one of the solution for x and y is that x is equal to 4 and y is equal to minus 3. Now, we have to figure out, is there any other way also in which this 8 can be written as a linear combination of 56 and 72? So, answer is yes, we can write. And how we can write? The step is, after writing this like 56 into 4 plus 72 into minus 3, what we have to do? We just have to add the product of 56 and 72 and subtract the product of 56 and 72. So how we can write it like this? Like plus 56 into 72, whatever was the linear combination we are writing, since we are writing the linear combination of 56 and 72, we will add the product of those and we will subtract the product of those, like subtracting 56 into 72 and adding 56 into 72. Now we can write it like this. We can make pair like 56 into 4 minus 56 into 72 plus 72 into minus 3 plus 56 into 72. So from these two, we can take 56 as common. If we take 56 as common, then we will be left in the bracket with 4 minus 72, which is minus 68. And taking 72 as common, we will be left with minus 3 plus 72, which is, sorry, minus 3 plus 56, which is 53. So again we can write this 8 as 56 into minus 68 plus 72 into 53. So it is another way of writing. So this is the way in which we can say that x and y are not unique. There can be some other values of x and y also possible. In the same way, if we do the same algorithm once again, we will get some other set of values. I hope you are getting it. Any doubt in this one? Okay, so let us try some of the word problems on the HCF. So like, okay, you want me to repeat presidency. So only the question was, the same set of question was there. Okay, so I'm saying the question was, till now we have done the expressing the HCF as a linear combination of 56 and 72. It was asking that represent, show that x and y are not unique. It means we have to show that there are some other values of x and y also which satisfy the relationship. So after doing till over here, this is the first set of values of x and y we are getting. Now to get another set of values of x and y, whatever was the initial numbers, in this question the initial numbers were 56 and 72. So what we will do, we will add the product of those, like over here, and subtract the product of those. So adding and subtracting the same number will not make any change in the expression, it will remain as it is. Now what we will do, we have to take, we have to combine these addition subtraction with the two numbers in the starting. So we have combined this 56 and 4 and 56 and minus 56 and 72. The first and the last we have added, and the middle two we have added over here. So 56 and into 4 minus 56 into 72. From here we can take 56 as common. So we will be left with 4 into 4 minus of 72 in the bracket. Like, let me write it once again so it will be more clear to you. When I take 56 as common, so I will be left with 4 minus 72, and from here when I take 72 as common, I will be left with minus 3 plus 56. So I will get 56 into minus 68 plus 72 into 53. So this is the another set of values of x and y. So we can also say x can be minus 68 and y can be 53 also. This is another set of values of x and y which satisfy the relationship. That's why we can say these are not unique. Got it, Presidency College? Okay then. So now let us try some of the word problems on the HCF. Like the first type of word problem is, like question says, find the largest number which divides Shillong, transposing in maths means we are shifting one of the things to another place. Like in the equation, when we shift something from left hand side to right hand side, we say transpose from left to right. That is the meaning of transposing, shifting. Itanagar, what was the what is your doubt? Like which step you didn't understand? So the question is like find the largest number which divides 245 and 1029, leaving remainder 5 in each case. So which is the largest number we have to find which divides 240. When we divide 245 and 1029 by that number, the remainder should be 5 in both of them. So try to do this. "54 Senavati." No. See, if I tell you like, suppose if 5 is the number and if I divide it by 2, right? So 2 times 2, that is 4. The remainder is coming out to be 1. So right now we can say that 5 is not divisible. Okay. Yes, Itanagar, that is right. Okay, I will not give you a hint so easily. Try once on your own. No, Senapati. Yes, Shillong, that is right. See, the largest number which divides 245 and 1029, leaving remainder 5 in each case. When we divide these two numbers by that number, the remainder is 5 in both of them. If we subtract the remainder, it means the resultant number will be exactly divisible. So what we will do, first of all, we have to subtract the remainder from these two numbers. So if we subtract the remainder, we will get 240, and here it is 1024. Now 1024 and 240, we have to find the largest number which divides both of them exactly. So it means the number which divides both of them exactly and the largest also is nothing but the HCF of 240 and 1024. So you can find the HCF by Euclid division algorithm. So that HCF comes out to be 16. So 16 is the largest number. So now when you divide 245 by 16, it will go up to 240 and remainder will be 5. Similarly, when you divide 1029 by 16, the remainder will also be 5. So 16 is the largest number which divides both of them, leaving remainder 5 in each case. Second question is also the same one, but here this time the remainder is different in each one. So what you have to do, subtract the remainders like we have done in the first one and then find the HCF. And one more thing, how you will find the HCF of 3 number using a division algorithm. Let me give you a quick hint. Suppose if we have these 3 numbers, we have to find the HCF. So first of all, find the HCF of the first 2 numbers. Whatever HCF you are getting, then this number and the third number, find the HCF of these 2. That will be the final HCF of all the 3 numbers. Find HCF of first 2 numbers, then the HCF of first 2 and the third number, find HCF of both of them, that will be the final HCF. Yes, Itanagar, that is right, the second answer. Senapati, that is not the right answer. Itanagar, that is correct. Tamenglong, this is correct. Yes, Itanagar, that is right now. Senapati, that is right. For the second one, we just have to find the HCF of, subtract all the remainders, like this. This is the answer for second one. Shillong, 17. And for this one, again, for the third one, we have to find the, it is asking find the length of the longest rod, which can measure 3 dimensions exactly. So longest rod, yeah, longest rod. So it which basically it's asking which divides all the 3 numbers. So the dimensions are like 8 meter, 25 centimeter. So you can convert all of them into centimeter to the single unit. So 1 meter is 100 centimeter. So it will be 825. This is 675 and this is 450. Centimeter, centimeter and centimeter. Now you can just find the HCF of these 3 number, 875, 825, 675 and 450. The HCF you will get as 75. So 75 centimeter. So 75 centimeter, this is the length of the longest rod which measures these dimensions exactly. All of you are getting it? Okay. Now after this, we have the next. This was the use of the Euclid division algorithm in finding HCF and different types of questions, variety of questions. After this one, we have the fundamental theorem of arithmetic. The next topic, the next theorem, the fundamental theorem of arithmetic. And using that theorem, we can also find the HCF and as well as the LCM also. So let us discuss what is that. So note down this heading. Fundamental So fundamental theorem of arithmetic, that is the statement. So it has two parts. Like first part says, note down this statement, every composite number. There are two numbers, prime number and composite number. Composite number are those numbers which have factors more than 2. So every composite number can be expressed So this statement says every composite number can be expressed as a product of prime, and this factorization is unique except for the order in which the prime factors occur. The meaning of this thing is that whatever composite number you are taking, that composite number can be expressed as the product of prime numbers, and that representation is unique. It means no other composite number will be represented by that factorization irrespective of the order. So it means the order does not matter. So like if we take a number as let's say 10, 10 is a composite number. So we can write this 10 as a product of prime number. So 10 can be written as 2 into 5. Now 2 is a prime number, 5 is a prime number, but 10 is a composite number. So I have written 10 as 2 into 5. So 2 into 5 will represent only 10. There is no such other number which will be represented by 2 into 5. That is known as factorization is unique. Factorization is unique means there will be only one way of representing any composite number as a product of prime. And except for the order in which the prime factor occur, it means either you can write as 2 into 5 or you can write this one as 5 into 2. Both are the same thing. Similarly, if we have 18, we can write 18 as 2 into 3 into 3. Now, no other number can be represented as 2 into 3 into 3 other than 18. So, only 18 is the number which can be represented as 2 into 3 into 3. Order does not matter. Like you can also write this one as 3 into 2 into 3 or 3 into 3 into 2. All of them represent the same number. So, this is known as fundamental theorem of arithmetic. All of you are getting it? Shillong, you are asking if 10 into 1, is this 10 into 1? See, 1 is not considered as a prime number. Prime numbers always starts from 2. 1 is not a prime number, or you can say 1 is neither prime nor composite. So 10 into 1 you have written 10 into 1 will be 10, which can be represented as 2 into 5. So write this thing about prime. Let me tell you the definition. Those numbers which have exactly two factors, that is 1 and number itself. That is the definition of prime number. composite number, numbers which have more than 2 factors. So prime number example are like 3, 2, 3, 5, 7, 11. These are the prime numbers. For composite number, we can take the example as 4, 6, 9, 10, 12. These are the composite number. And yeah, negative number can also be prime. It is just the sign. Negative number, like minus 2 is also a prime number. Minus 7 is also a prime number. And make sure one more point, 2 is the only even prime number. 2 is the only even prime number, rest of the prime numbers are odd. No, decimal is not prime. Prime numbers are the part of the integers. So decimal does not counted in integers. Yes, in the positive, if you are talking about, yes, Itanagar, if you are talking about the positive, 2, if you are talking about only the positive numbers, then 2 is the smallest positive prime number and it is also the smallest even prime number. And if you are talking about the negative ones, then it is a different thing. But generally, if you are talking about the prime number, we talk about only the positive ones. Getting it? Now the second part of this one, fundamental theorem of arithmetic, B part, it says, let P be a prime number and A be a positive integer. So if P is a prime number and A is a positive integer, if it is given that P divides A square, then P also divides A. That is the result of this thing. If P is a prime number and A is any positive number, a positive integer, if it is given that P divides A square, then P also divides A. The meaning of this thing is that if we understand with the help of example, suppose a prime number P is equal to 3 and let's say A square, let's say any perfect square number, let's say P should be divided A square. So let's say we can take 81, right? So here P divides A square. So if A square is 81, so you can see over here, if P divides 81, so P divides 81 or 3 divides 81 27 times. So 3 divides 81 we can write. So 3 also divides 9. 9 is the square root of 81. So 3 also divides 9. That is the statement of this theorem. For this case, P has to be the prime number. If P is dividing any perfect square, then P will also divide the square root of that one. We can take one more example. Let's say if P is equal to 5 and A is equal to A square, let's say 625. So we know that 5 divides 625 for some integer. So square root of 625 is 25. So 5 also divides 25. It implies that 5 also divides 25. That is the meaning. Getting these two theorems? So first theorem which we have discussed is every composite number can be written as a product of prime in a unique way. Second one is if P is a prime number and if it is dividing and A is any integer. So if it is dividing A square, then P will also divide A. These are the two results of these theorem. So we will use both of them. The second one, which is P divides A square or P divides A, we will use this one in proving of irrational numbers. And the other one we will use in the fundamental theorem of arithmetic, the prime factorization way, we will use it to find the HCF and LCM of the two numbers or three numbers. Like a very first question, a very basic one. It can be asked like this. Express 140 as a product of prime factors. So express 140 as a product of prime factors. So this one you already know, you have done it so many times. So we can write it like 1 for prime factorization of 40 we have to do 140. So 2 times 70 it will go, then 2 times 35, then 5 times 7, then 7 times 1. So we can write 140 as 2 into 2 into 5 into 7. So this is known as the expressing 140 as a product of prime factors. And this one is unique. No other number can be represented as 2 into 2 into 5 into 7. Only 140 is the number which can be represented like this. Shillong, it should be 5 oblique this 25, because in the starting I have told you if it is done A like this, it means A divides B. So here A is the divisor, B is the dividend. So same over here also, 5 is the divisor and this is the dividend. This is the vertical sign. This is a vertical line. This vertical line, this is not a oblique. It is a straight vertical line. Like a straight vertical line it is. The meaning of this line is that if I am writing two numbers on the left and right of this one, it means left one divides the right one. That is the meaning. Only the vertical line is used to represent that left number is dividing the right number. Getting it? So the first one is the like express 140 as a product of prime factors. Why is it 25? See, the question was if P divides A square, then P also divides A. So a square and a is the square root of a square. So I have already taken 625. So 625 is the perfect square. So if a square is equal to 25, then a has to be 25, square root of 625. CC4, you are not getting it. See, this 25 is not coming by dividing 625 by 5. I have written 25 as the square root of 625. Like, let's take one more thing. If it is written, so here P is 5 and a square is 625. So it is written, if P divides a square, it implies P divides a. So here a is the square root of a square. So square root of 625, that is coming out to be 25. It is not coming by dividing 625 by 5. This 25 is the square root of 625. Let us take one more example. Like, so 2 divides 64. So 2 is a prime number and 2 divides 64. So 2 will also divide the square root of 64. So square root of 64 is 8. So 2 also divides 8. That is the meaning of this statement. Is he not there? Sonu? Getting it? Okay, so let us end our class over here. That's all for today. So in the next class, what we will learn? We will learn how to solve the questions on finding the HCF and LCM using fundamental theorem of arithmetic. And then we will also learn how we can prove that the given number is irrational. In the 9th class, you learned what is the irrational number. In the 10th class, we will prove using this second theorem, like why this given number is irrational number. That we will discuss in the next class. So till then, practice those things like finding the HCF and representing that as a linear combination. And second one is this thing, fundamental theorem of arithmetic, writing the number as a product of prime numbers and finding word problems on the HCF. That you can do till the next class. Okay then, thank you.